Okay, so get this. Just yesterday, a paper dropped that cracks a really deep mathematical puzzle, and in doing so, it revealed this hidden layer of reality inside some of the most complex shapes you can even imagine. Today, we're going to unpack the story of this incredible breakthrough.
So let's dive right in. I want you to think of this as a kind of mathematical detective story. We are about to uncover a secret message, one that was written in a sort of invisible ink, hiding in plain sight for years and years.
All right, so first things first. To really get what's going on here, we need to understand the scene of the crime. The beautiful, incredibly complex, and, let's be honest, sometimes baffling world of fractals. Now, we've all seen how beautiful a fractal can be, like a snowflake. But for a mathematician, creating a perfect formula, a perfect map to describe one, well, that's a massive challenge. It's kind of like trying to draw a map of a coastline that has an infinite amount of detail. That's the level of complexity we're dealing with. Our story zooms in on a particularly tough group of these fractals called non-holomorphic families. Now, all you need to know is that these are the messy ones. They don't follow the nice, smooth, predictable rules that mathematicians love. For years, they've been one of the most stubborn mysteries in the whole field.
So here's where it gets really interesting. It's all about how mathematicians tried to map these fractals and the very specific, very strange wall they kept hitting.
The main tool for this whole investigation is this mathematical technique called the Watson expansion. The easiest way to think about it is like a superpowered magnifying glass. It's designed to look at these fractals at incredibly tiny scales to figure out the exact recipe that creates them.
And this gets us right to the heart of the mystery. Using this mathematical magnifying glass, researchers came up with a formula that was, well, it was almost perfect. It described pretty much the whole fractal structure, but there was always this tiny, nagging error, this ghost in the data that just wouldn't go away.
And look, this wasn't just some minor bug. This was a famous cold case in the field, officially known as Open Problems 1 and 2. Everybody knew about this ghost in the machine, but absolutely nobody could explain it. All right, so here comes the first breakthrough. It happened when the researcher Michael Bird decided to focus his investigation on one specific family of these fractals, a group known as Class A.
And bam, there it is, the aha moment. The reason the formula was always slightly off wasn't because there was a mistake in the math everyone could see. It was because the formula itself was incomplete. It was missing a whole separate hidden piece.
So basically, there were two things happening at the same time. You had the main signal, that's the obvious part of the formula everyone was studying, but underneath it all, there was a second, hidden signal, almost like it was being broadcast on a totally different frequency that was just getting drowned out.
The paper actually describes this hidden part as invisible to any finite truncation of the Watson series. What that means, in plain English, is that you could use that powerful magnifying glass to zoom in on the main formula forever, and you would never, ever find a trace of this second part. It was truly hidden.
So, case closed, right? This invisible ink thing was the missing clue that solved the whole puzzle. Well, not so fast. So the next logical question for any good detective is, okay, does this clever two-part solution work for all the other mysterious fractals?
The answer, amazingly, was not even close.
It turns out the rabbit hole went way deeper. When the researcher used the same methods on a related family, the Class B fractals, that whole invisible ink trick just didn't work. The ghost in their machine was being caused by something else entirely.
And this is where the discovery gets really, really wild. Class B fractals don't have that simple two-part structure. Instead, they follow a totally different, much stranger set of rules that the paper calls an iterated-logarithm series. It's described as exotic because it is a fundamentally different and more complex kind of pattern. It's a whole new mathematical beast.
So what in the world does all this mean? It means the entire case file on these fractals has just been blown wide open, with two of the biggest mysteries officially put to rest.
When you boil it all down, this one single paper pulls off a triple win. First, it slams the book shut on those two long-standing open problems. Second, it gives us the complete, correct formula for all Class A fractals. And third, it uncovers the fundamentally different and way stranger nature of Class B.
The big takeaway here is that our map of this corner of the mathematical universe just got a massive update. It's more complete, it's more accurate, and honestly, it shows us that the reality behind these shapes is far stranger and more varied than anybody ever imagined.
And that leaves us with a pretty fascinating final thought. I mean, if a whole layer of math could be hiding, completely invisible, inside these formulas, what else is out there, just waiting for us in the gaps of what we think we know?